Welcome. In this video I'll cover how you can create clouds like these you currently can see on the screen. These are three-dimensional clouds consisting of only spheres which use the fluffy shader. I showed you how to create them in the last video. If you haven't watched it, it is a prerequisite for this video, so you will probably need to watch this to understand this shader, because we will duplicate the fluffy shader and modify it to make it suited for these clouds. What we need to do is to copy the full gradient noise part at the top and blend both pieces together. We do this to create a triplanar shader out of this, so that the clouds look always the same no matter what size they are, and we won't have problems with the UVs. So plug position nodes which are set to world space into the UVs of the tiling and offset on the first one, and on the other one to fix some issues which would be caused, we need to put a rotate about axis node in between and rotate it by 90 degrees on the y-axis, and plug that in like we did above. Now the shader is basically already triplanar. Create a material to see the changes and apply that material to a sphere. You can see there are no visible seams and it works just fine. But there's an issue with the negative alpha values you can see here. We need to clamp the alpha values at the end so that they don't go above 1 or below 0. And just put the clamp node in and you will be fine. There won't be this issue anymore. Now adjust the values to make it look like a cloud, but for now this doesn't matter, we will change it later. But for one cloud you're basically done now. The rest is to create a system, an object that spawns the clouds and make the clouds moving and have a random size. We will create C# scripts to make that happen. First I'll create the script for the cloud spawner to create lots of clouds when the game is started. Create some properties, a float for the height at which the clouds should spawn, another float for the height variation, an int for the amount of clouds we want to spawn, the prefab itself to get the object we want to spawn. We will create a sphere to put in there later. create a simple for loop, replace length with the cloud amount, and instantiate a cloud each time. This will instantiate the amount of clouds we set. Now we still need to define a spawn area. This isn't vector 3 because I wanted to make it simpler, so it just will be a box with the size of a spawn area on the X and Z axis and the size of the height variation on the Y axis. Now define the spawn position that we will put in the instantiate function. Make the position on the X, Y and Z axis random. So we will have a bunch of randomly distributed clouds later. What I forgot here was that the random range function needs one minimal value and one maximum value. So we also need to feed in the position of the cloud spawner object itself. We will make the minimum value minus the spawn area and the maximum value plus the spawn area. Take the X position first, then for the next one we will use the spawn height and add and subtract the height variation for the minimum and maximum values. For the Z we can just copy our code for the X and replace the transform.position.x with transform.position.z. For the Y I forgot that I should use the spawn height and height variation here, so I need to change it right here. As I said, one time the spawn height minus the height variation, and for the maximum the spawn height plus the height variation. Now we can put the spawn position in. For the rotation we will use the quaternion.identity for a similar rotation for all the objects. And as a parent object we will use the cloud spawner itself. I'll deactivate my old cloud spawner here and create a new object where we can apply our newly created script. Now we need to create the sphere object that we will create a prefab of to use it as the object that shall spawn. Assign the material. drag it into the hierarchy to create a prefab. Now we can use this prefab on the cloud spawner and put in some values for the spawn height, the height variation. 500 as the height variation might be a bit too high. Define a spawn area and an amount of clouds to spawn. Let's test this out. The first time it takes a little while because it creates such an enormous amount of spheres. As you can see, the spheres are way too little and don't really look like clouds yet. They were a little much too distributed, so I set down the height variation to 150. Now we need to create a script for the spheres to let them have a random and a bigger size and let them change their position over time. So we will create a float for the size. Another float for the speed. And in the update we can modify their position using the transform.translate function. We will use the vector 3.right, but you could also use the forward, left or other values, but I decided to use the vector 3.right. But it doesn't really matter as long as you don't change the position on the y-axis. So you shouldn't use vector 3.up or down. First I had the idea to have it have different values for each axis for the scale, but I think that's not the best idea. It could look very off depending on whether maybe some axes will get very low and others very high values. That might look pretty bad and not like clouds. So I decided to keep the more round shape of the sphere. Put the size random into every vector of the vector 3 and set a scale to this vector 3. But I decided to create another float, a y multiplier, to make it a little smaller on the y-axis, so it isn't a perfect sphere anymore. We need to change some values to make it look like clouds. I figured out that 0.01 for the noise scale is good, a Fresnel power of about 0.5 to 0.8, the additional power to 8 and the push out about a little below 1 looks good for this cloud size, but of course it depends on how big you choose your clouds to be. Now we need to edit the prefab of the cloud to assign the newly created script. In my opinion, a size of 300 to 500 looks good, and the Y multiplier of 0.8, so it's just a little smaller on the Y, but not a lot. And if we start it now, we already see it looks like clouds. Right now the clouds look very light. If you like it like that, that's fine, but I think I want more dense clouds, so I decide to lower the spawn area, but keep the cloud amount the same, so that they are less spaced. And as we can see, it looks pretty good. We have a dense cloud. You can see some flickering happen, but I don't know how to fix it. It's because of the surface type of the shader set to transparent, but if you set it to opaque, you could only use the alpha clip value and nothing in between, so that is not an option for this type of cloud. So we have no other choice than to accept that there's some flickering, but it doesn't look too awful. If you don't get too close to the clouds, you barely see it.